We now solve LeetCode problem 669, trim a binary search tree. Given the root of a binary search tree and the lowest and highest boundaries, low and high, trim the tree so that all its elements lies in low and high. All right, so here's an example. You've got 0, 1, 2, and low is 1, high is 2. When you trim this, all keys that do not fall in this range has to be cut out. So you are left with the 3, 1, and 2. 1 and 2 are in the range 1 and 2. Here's another example. You've got a binary search tree of this shape, and the boundaries are 1 and 3. So all keys that are out of this range, 1 or 1, 3, have to be cut out, and everything that are within in this range have to be left behind. And in this case, 0 and 4 are out of the range, so they have to be cut out, and we are left with this binary search tree. So the way to solve this problem is the following. Here is our range, 1 and 2. We look at the root node. Is it in the range? If it is in the range, it stays, right? Then we say trim the left subtree and make it the new left subtree of this root, and trim the right subtree and make it the right subtree of this root. Now we go into the left side. So this is the left side now. We look at the root. Is it in the range? No. So that means if root is not in the range, then there are two cases. If 0 is less than the left bound, which is the case in this example, then we need to recursively trim the right subtree and return that as our result. In this case, of course, the right subtree is null, so that means you're going to return null from here, and that would be the next left subtree. And then we recurse on the right subtree with the bound 1, 2. And as you can see, 2 is in the bound, in this range. So we are going to recursively trim the left subtree, which is null, recursively trim the right subtree, which is null, and then return the new root to the right subtree, which is again 2. And this is what we are left with. Let's now look at this example. This is the given binary search tree. Our range is 1 to 3. We start at the root. Is 3 in this range? Yes, that means 3 has to be part of the resulting binary search tree. So that stays. Now we are saying recursively trim the left subtree. So we come here, the left subtree. Now we compare root if it is in the range. Is root in the range? No, it's not in the range. 0 is actually smaller than our left bound. If what's stored in the root is smaller than our left bound, not only we trim off the root, but also we trim everything on the left subtree, because everything on the left subtree is less than what's stored in the root. If root is less than the bound, the left bound, then also everything that's stored on the left subtree has to be smaller than the left bound. So not only the root goes, but also everything on the left subtree must also be trimmed away. So the solution is only trimming the right subtree, which is here. So we come here, we look at 2, is it in the range? Yes. Then we say, okay, this stays, as you can see, it stays. And trim the left subtree, so you come here, 1, is 1 in the range? Yes, it stays. Of course, trim the left subtree, trim the right subtree, both are null, so we should be getting null. And we come back, trim the right subtree here. So the right subtree of 2 is also null, so you're getting null from here. So that means what's left on the left subtree is only 2 and 1. And we come back to the root and do trimming of the right subtree. Now we go to 4. Is 4 in the range? No. Is 4 less than 1? No. It is. If it is it less than 3? Yes. That means we are going to trim. We are going to trim 3 and also return what's the trim of the left subtree, which is going to be null, and that's what we are going to be left with. And here is the code for it. So the idea is the following. Again, if the root is equal to null, return null. If what's stored in the root is greater than high, remember this is our range from low to high. If what's stored in the value in the root is greater than high, that means not only the root is greater than the right bound, but also everything on the right subtree. So the resulting trim should be only trimming the left subtree within this for this bound. And if what's stored in the root is less than the lower bound, not only we have to trim the root, but also everything on the left subtree, because that means the root and everything that's stored on the left subtree is not in the bound. So we only return the trimming of the right subtree. Otherwise, the root stays. Now we are saying root.left is equal to trim the left subtree, and root.right is equal to trim the right subtree, and finally return the root. So let me run this thing so that we actually see that it works. There you go. It's very fast and a very clean code. Any questions you might have, please leave them in the comments section.